Hello, lovely people. Hope you're doing well. Welcome back to another higher plus 5 a day. Let's get straight into it. So here we've got two functions, f of x equals x plus 3 and g of x is equal to x squared. And we're doing g of f of x. So we're essentially putting f of x into g of x. Okay, so instead of doing x squared, we're actually putting f of x into that. So it becomes f of x squared. But what is f of x? It's x plus 3 all squared, like this. And that is equivalent to, of course, x plus 3 multiplied by x plus 3. And when you expand that and simplify it, it becomes x squared plus 6x plus 9. Lovely stuff. Next question, guys. Next, calculate an estimate of the gradient of the curve at x equals 3. So if you saw my other video, you'll have seen my gross blunder. Whew, wow. What I'm going to do is draw a tangent at the point where x is equal to 3. So that's going to be here. And, oh, that is kind of nice. That's all right. That is not a bad tangent, I think. I haven't even drawn the tangent yet and I'm already complimenting it. Oh, dear. Okay, that's kind of okay. What points does it go from? Looking for nice points. Looking for nice points that it goes through because I need to work out the gradient of my tangent because that would be an estimate for the gradient. This one looks good. So that's going to be 4.86 based on the scales that I'm seeing. I guess I can actually pick the point itself. So 316. So I have x1, y1 as my coordinates, x2, y2, and the formula for gradient is y2 minus y1 over x2 minus x1. So change in y over change in x. Now my change in y is going to be y2 minus y1, which is 16 minus 6 over 3 minus 4.8. That's 10 over minus 1.8 or minus 100 over 18 if we like, or dividing both by top and bottom by 2 minus 50 over 9. There are quite a few ways in which we can express this. I mean, take your options. Take your options. Okay. I guess we could give a decimal equivalent for this as well. So 50 divided by 9 is what, like 5.5 recurring? So minus 5.5 recurring. But yeah, something like this is fine. Next, find an estimate of the area between the curve and the x-axis between x equals 0 and x equals 5. Okay, so we want to know the area. It's going to be approximate. So what we can do is just split this up into different trapezia. So let's go here. So there's one there, one trapezium. And I'm actually going to do another trapezium, little one over here. So I've got two fairly big trapezia and I've got a smaller one. I'm just going to rub out the rest of what was put. And we're going to do it like that. So there we go. So for my first trapezium, I've got 25 as a one of the parallel sides, 21 as another parallel side, and I've got 2. So half the sum of the parallel sides times the height between them. That is how you find the area of a trapezium. So the parallel sides added and halved times the height between them. So that's for one trapezium. The next trapezium, we've got a height here of, I'm going to go for 9. It goes up to 9. So that's going to be, again, half the sum of the parallel sides times the height between them. That is how you find the area of a trapezium. So you've got 21 plus 9 all over 2, and then times that by the height between them, which again is 2 between here. And then plus, lastly, we've got a nice triangle. So it's basically just half the base times height. So that's going to be 9 plus, or it's just 9 actually. 9 times, rather, the base, which is 1, and then divided by 2. So for this first one, I've got 25 plus 21 times 2 over 2, but that's just going to be equal to 46. Next one I have 21 plus 9 over 2 times 2 is going to be 30. And the next one is going to be 4.5. So 46 plus 30 is 76, plus 4.5 is 80.5. So I've got about 80.5 units squared. Right, let's move on to the next one. So the histogram shows the heights of 2,400 sunflowers. Fun times. And it says find an estimate of the median. Well, first of all, we need to work out, so the median is going to be essentially halfway. So you could do the whole plus 1, then divide by 2. But you could also just divide by 2. Because it's such a big number and you're working out an estimate, it doesn't matter so much that we do the whole adding 1 and dividing by 2. So we can look for data point number 1,200, or the 1200th piece of data, or 1,200th piece of data. So between in the first bar, remember frequency in a histogram is the area of the bar. So we've got, what number is this? 25, 50, 75. 75 multiplied by, is that 8? Is that, yeah. Okay, so the 600, I think it is. So this would be 600. Then you've got 50 times by 16. That should be 800. Yep. Then you've got 50 times 20 is 1,000. Gosh, these are getting bigger. 1,000. Oh no, I lied. It's not. It's 25 times 20, which is only 500. It didn't look big. Yep, 500. Oops. And then the next one, oh, that's so awkward. In fact, actually, I don't actually have to work it out, do I? Because I know it's 2,400 sunflowers in total. So 600 plus 800 is 1,400. Plus 500 is 1,900. Therefore, this last bit is going to be 500. I know that. Doesn't quite look right though, does it? Oh no, it does. Yeah, it does actually. Okay, calm. 2 sunflowers are selected at random. No, I still need to do the first part, don't I? Find an estimate of the median. So if we're looking for the data point number 1,200, well, between 600, up to 600, it's only 600 pieces of data. Up to the second bar, that is 1,400, because that's 600 plus 800, which is 1,400. But we only want to go up to 1,200. So we need to split this bar in such a way that we can interpolate this. So if I were to split this 800 bar into, say, 4 pieces, so I'm going to use my ruler for this. If the total area is 800, then me splitting it in half means that one side would be about 400 and the other side would be about 400, right? I'm going to do the same here. I'm going to split it into 4 pieces so that each of them is worth 200. Now you'll see in a moment why I'm doing this. The point of this is up to here is 600. This bit represents, this section represents 200 because I've split this 800 bar into 4. So that takes us to 800 pieces of data in total. Over here is another 200, taking us to 1,000. And here, or up to this end bar, would be 1,200. So the 1,200th data point would be this point here. So if I've split this interval into 4 pieces, so from 75 to 125, that is 50. 50 over 4 is about 12.5. And each of these jumps would be 12.5, 12.5, 12.5. 12.5 times 3 is equal to 37.5. So I need to do 75 plus 37.5 to work out what number this represents, basically. 75 plus 37.5. So let's do that. 75 plus 37.5. Yes, I'm shamelessly using my calculator, which is 112.5. So that's a good estimate there for the median. 112.5. Quite a long one, I think. Next, 2 sunflowers are selected at random. Calculate an estimate of the probability that both sunflowers have a height greater than 2 meters. Okay, so I'm just gonna rub out the bits I don't quite need. So basically, we're going up to this point here, right? So we know that this first bar was 600, the second bar was 800, the third bar was 500. So 600, in fact, let me write in a different color so that we know it's a different question that we're doing altogether. Oops. So we have 600 plus 800 for the second bar plus 500. And we know the last one was also 500, but we split that in half, so plus 250. So basically, we know that the number of sunflowers greater than 200 is going to have to be 250, right? So this bit would be 2150. To work out the remaining, 2,400, take away 2,150, which is 250. Or you could have just calculated the area of the end bit. Point is, I now know it's about 250 sunflowers that are greater than 2 meters, 200 centimeters. So the probability of one of them being greater is 250 over 2,400, over 2,400, the total number. Now, at this stage, because it's 2 sunflowers that are selected at random and it doesn't imply replacement, you would want to do 250 over 2,400 times 250 over 2,400 like this. However, if you've taken one sunflower out, then you're going to have one fewer sunflower that is above 200, that's above 2 meters. So that's going to be 249 out of, and it's also one fewer sunflower in total, so 2399. Okay, so let's just calculate that. So 250 times 249, oh my God, 62250 over 2400 times 2399, which is, oh gosh, 5,757,600. 100. And then I'm going to do 62250 divided by the answer. 5757 600. And that's about 0.01 to 2 decimal places. So there we go. These questions kind of make you think. Yeah, they're trying to get you, but as we work through this, you start to realize that there's only so much they can ask you. So if you can do these questions, you're in a good position when it comes to the actual GCSE. Anyway, take care for now, guys. Goodbye.